Good morning. Today we are going to discuss the fourth model of an atom which is in use today. It is called quantum mechanical model. Now first let us see what are the developments that led to the formulation of quantum mechanical model. Developments that led to the formulation of quantum mechanical model. Now, there are two important principles that led to the formulation of quantum mechanical model. The first is called de Broglie relationship. De Broglie relationship. Now, de Broglie suggested that like light, matter also possesses dual character. That is, matter also has wave-like and particle-like property. Just like a photon has momentum and wavelength, electron also has momentum and wavelength. So, de Broglie gave a relationship between the momentum and wavelength of a particle. And the relation was found like this, that is from wave character and particle character. Now we know according to Planck's quantum theory, we have E is equal to h nu. Let's give this equation number 1. And this is on the basis of Planck's quantum theory, and Planck's quantum theory was the basis for the formulation of wave character of radiation. Now next is based on the particle character, Einstein gave the relation E is equal to mc square. Let's give this equation number 2. Now combining 1 and 2, we get h nu is equal to mc square. Now nu, h is Planck's constant, nu is the frequency, m is the mass of electron and c is the velocity of light. And substituting for nu is equal to c by lambda, you can write h into c by lambda is equal to mc square. Or we can write from this expression lambda is equal to h by mc. Now we know this m into c, that is mass into velocity, is equal to momentum p. So we can write the expression as lambda is equal to h by p. So this is de Broglie's relationship, that is the relation between wavelength and momentum of a particle. Wavelength and momentum, you can see from the equation they are inversely proportional. So this relation helped in the formulation of quantum mechanical model. Now the next development that led to the formulation of the quantum mechanical model is Heisenberg's uncertainty principle. So second one is Heisenberg's uncertainty principle. Now, what is Heisenberg's uncertainty principle? It states that it is not possible to determine simultaneously the exact position and exact momentum or velocity of an electron. This is Heisenberg's uncertainty principle. That is, it is not possible to determine simultaneously the exact position and exact momentum, and you know momentum is mass into velocity, which means mass will remain constant. So exact momentum means exact velocity of an electron, and mathematically this can be represented as, or the mathematical expression for Heisenberg's uncertainty principle is delta x into delta p greater than or equal to h by 4 pi, where delta x is the uncertainty in position and delta P is the uncertainty in momentum. Now, I am going to substitute instead of delta P, delta mv, mass into velocity. So, delta x into delta mv is greater than or equal to h by 4 pi. Or you can see mass is a constant, so I am going to take it out. So, delta x into m delta v greater than or equal to h by 4 pi. Or I can write delta x into delta v greater than or equal to h by 4 pi n. So, the statement is, this is the mathematical expression for Heisenberg's uncertainty principle. The statement is, it is not possible to find the exact position and exact velocity of an electron. So, we know that in an atom, the electrons move in a well-defined circular path called orbits. But after studying Heisenberg's uncertainty principle, and we know in the orbit the electron moves with a particular velocity, and we can also identify the position because it is a circular path. But after studying this Heisenberg's uncertainty principle, it is found that we cannot find the exact position and exact velocity of an electron in an atom, which means this Heisenberg's uncertainty principle rules out the existence of orbit in an atom. So, now the concept of orbit is outruled, it is not present. Okay, so we have another concept called orbital present in an atom. Now, these are the two important theories that led to the formulation of quantum mechanical model. Now, you will learn about the orbital, the concept of orbital in quantum mechanical model. Now, we don't have the concept of orbit anymore after Heisenberg's uncertainty principle. So, let's see what is quantum mechanical model. So, next is quantum mechanical model. Now, this model of atom was developed on the basis of de Broglie's theory and Heisenberg's uncertainty principle. And in this model, the behavior of electron in an atom is given by Schrödinger wave equation. So, the behavior of electron is given by a very important equation in quantum mechanical model, and it is called Schrödinger wave equation, and that equation is H psi is equal to E psi. Now, psi means it is the wave function and it represents the amplitude of electron wave. And when this equation is solved for psi, and H is called the Hamiltonian operator, psi is the wave function, E is the energy, and when this equation was solved, we got three integers for psi. It is called N, L and M. And this N, L and M are called quantum numbers, which give lot of information about an electron present in the atom, which you will learn about the quantum numbers in the next video. Okay, so this psi, when it was solved, psi has three values N, L and M. Now we have another term called psi square. Psi square means it is called the probability density. Probability density means it gives the intensity of finding the electron at a particular point. That is probability density, because now after Heisenberg's uncertainty principle, we don't have a particular position for finding the electron. So, psi square means the probability density, means the probability of finding the electron at a particular point, that is probability density. Now, before we see the important features or postulates of quantum mechanical model, let's see what are the main differences between orbit and orbital. And I told you now we don't have the concept of orbit, we have only the concept of orbital. But let's see what are the differences between orbit and orbital. Orbit and orbital. Now, you know what is an orbit. Orbit is a well-defined circular path around the nucleus of an atom in which the electron is moving. So, if we are asked to draw an orbit, you can draw nucleus at the center and a circular path where the electron is moving. This is orbit. Now, orbital means it is the region of space around the nucleus where there is maximum probability of finding an electron. So, orbital means we consider some region around the nucleus where there is maximum probability of finding the electron. So, if you are asked to draw an orbital, you can draw again nucleus at the center and we will denote with dotted line around the nucleus. And this dotted lines represent somewhere around the nucleus there is maximum probability of finding the electron. So, this is the main difference between orbit and orbital. In orbit we can predict exact position of electron, but in orbital we get only the probability of finding an electron around the nucleus. Now, the next difference is orbit represents two-dimensional motion of an electron, whereas orbital represents three-dimensional motion of an electron. The third difference is orbits are circular in shape and orbitals are of different shapes. So, we have orbitals with different shapes. Now, the fourth difference is the maximum number of electrons that can be placed in an orbit can be obtained from the formula 2n squared, and the orbital can accommodate only 2 electrons. Okay, so the orbit can accommodate 2n square electron, and where n, what is n? N is the number of orbit, where n is equal to 1, 2, 3, etc. Whereas the maximum number of electron that an orbital can accommodate is only 2. Now, next difference is orbits are non-directional in nature, non-directional, and they do not explain the shape of molecules. So, non-directional because it is circular in shape, and you know there is only one direction, circle, round. So, there is no directional character for orbit, and this orbit cannot explain the shape of a molecule. Whereas orbitals are directional in nature. They have directional property and they can explain the shape of molecules. So, here orbitals have directional character, directional property, and explain shape of molecule. Now, the last difference is the concept of orbit is against Heisenberg's uncertainty principle, whereas the concept of orbital is in accordance with Heisenberg's uncertainty principle. So, the last one is, this is against, orbit is against Heisenberg's principle, whereas orbital is in accordance with Heisenberg's principle. So, these are the differences between orbit and orbital. So, orbit means well-defined circular path around the nucleus where the electron revolves, and orbital is the region of space around the nucleus where there is maximum probability of finding an electron. Second is orbits are two-dimensional, orbital is three-dimensional. Orbits are circular in shape, orbitals have different shape. Maximum number of electrons that can be placed in an orbit is 2n square, wherein is the orbit number, and only 2 electrons can be placed in any orbital. Now, orbits are non-directional in character and do not explain the shape of molecule, whereas orbitals are directional in character and they explain the shape of molecules. And the orbit, the concept of orbit is against Heisenberg's uncertainty principle, whereas concept of orbital is in accordance with Heisenberg's uncertainty principle. Now next let us see the important features of quantum mechanical model. So the first feature of quantum mechanical model is the energy of electron in atom is quantized. Energy of electron in an atom is quantized. Quantized means it is fixed. That is, they can have only a certain specific values. Now the second feature is the existence of quantized electronic energy level is a direct result of wave-like properties of electrons, and they are the allowed solutions of Schrödinger wave equation. Now the third feature of quantum mechanical model is both exact position and exact velocity of an electron in an atom cannot be determined simultaneously. Now, that is why we talk only about the probability of finding the electron at different points in an atom. Now, the next fourth important feature is an atomic orbital is the wave function psi for an electron in an atom. In each orbital, the electron has a definite energy. An orbital cannot contain more than 2 electrons. And in a multi-electron atom means atom which contain more than 2 or more than 2 electrons. The electrons are filled in various orbitals in the order of increasing energy. Now for each electron of a multi-electron atom, there would be an orbital wave function characteristic of the orbital it occupies. Now the last feature is the probability of finding an electron at a point within an atom is proportional to square of orbital wave function psi square, and psi square is called the probability density, and it is always positive. From the value of psi square at different points within an atom, it is possible to predict the region around the nucleus where electron will be most probably found. So these are the important features of quantum mechanical model, and the explanation of these features will be in the next video. That is when we are going to study the quantum numbers. I told you when we solved that expression for psi, h psi is equal to E psi, we got 3 quantum numbers n, l and n. So the explanation about quantum mechanical model will be in quantum numbers. So with this, the basic things related to quantum mechanical model is over. So the main difference is in quantum mechanical model, we don't have the concept of orbit, we have only the concept of orbital. Thank you.